All right, so we're moving into functions. So this is the beginning of test 4. So just logistics, you're going to be drawing a lot of pictures like this, where you're going to have X as a set 1, 3, 5. So I'm going to encourage you to put the numbers on one side, on the left side, and then put the dots on the right-hand side, because you're going to be drawing arrows. And then if I have the set Y, and put the dots here on the inside, for S, T, U, and V. Okay, so we're defining this function f going from X to Y. Okay, so let me give you what the function is. I'm just going to tell you it so you don't have to figure it out, right? So 1 goes to S, 3 goes to S, and 5 goes to U. Okay, so that's defined for you. Okay, so what's the domain of this function? So the domain would be the set 1, 3, and 5. So what's the codomain? The codomain, we've done this in linear algebra, right, is everywhere you could go. And so what's the range? The range are the values that are hit. So it's just S and U. So is 3 an inverse image of S? So here's S. Is 3 an inverse image, meaning going the other direction? Yes. Is 1 an inverse image of U? No. No, U does not go to 1, so that's not true. Okay, so represent F as a set of ordered pairs. So I would have 1 from X and S from Y, and I would have 3 and then S, and then I would have 5 and then U. Whoops, that doesn't look like an S, does it? Okay, there we go. So those are the ordered pairs. So notice all elements of the domain, so all elements of the domain must be acted on. So it means there's always, every element in the domain has an arrow coming out of it. That's not necessarily true in the codomain, correct? Because the codomain does not equal the range. We kind of see how that works. Okay. So let's get you to be creative. Let me make a little more space here. So find all the different functions that go from this set to this set. So let's just do it by pictures. So if I have the set here, here would be A, and here would be B, for that's the set X, and here's the set Y. And again, I'm just going to encourage you to put the dots on the inside, right? So I have the simple case, A going to U, B going to V, all right? So then here I have A and B and U and V. So now I could have A going to V and B going to U. Whoops, that's supposed to be a Y. So X and Y. So let's think about it. So remember, everything in the domain has to go to something, has to be acted on, right? So A could go to U and B could go to U, right? That's an okay thing to do. And then I could have, here's A, here's B, U and V, and so they both could go to V, right? Okay, so let's talk about how many functions, and we're going to be doing more of this counting thing for our next test. But if I have 3 elements here, and I have 4 elements here, how many different functions? So this element here would have, right, this element here would have 1, 2, 3, 4 choices, right? So this element has 4 choices. This element here has another 4 choices. And this element here has 4 choices, right? Because they all could go to the same one, right? So it doesn't matter. So they each have 4 choices. So that would be 4 cubed. That would be the number of functions. So what we cannot have, let's make sure we cannot have, if I have like these elements here, and 1, 2, 3, 4. Okay, so this element here cannot have 2 arrows coming out of it, right? You can't say, oh, this element here sometimes goes here and sometimes goes here. So this is really wrong, right? an element in the domain cannot have two arrows coming out of it. I can have an element in the codomain having two elements going to it, but not in the domain. Okay, so how many functions would there be? So let's generalize it from a set with m elements to a set with n elements. So that for each of these m elements, I would have n choices, right? So that would have, so each of these would have n choices. So I would have n to the m, right? Each of these, so I would have n to the m. Okay. And you can see this is like the 3 and the 4, right? All right. Beating that horse to death. There we go. So here we're going to get into some very different kinds of functions. So here's the function f, and it's going from the power set to the integers. So the power set of what? The power set of a. So all the sets of subsets that can be made from here, right? Which you are very familiar with now. Okay, so the function will give us 0 if the subset, right? The subset that's in the power set of A, the function will give me 0 if the subset has an even number of elements, and the function will give me the number 1 if the subset has an odd number of elements. Okay, so here we go. So this is an element in the power set of A because it's a set of subsets. So since there's an odd number of elements, I get 1 out of here. All right. So here I have a subset 2, 3. Since there's an even number of elements, I get the number 0 from the function. And here I have the null set, which is in the power set of A. How many elements are there? 0. And we know 0 is an even number, so that means I get 0.